All right, so welcome back to Mr. G's lab. Today we're going to focus on molar mass and figuring out how much a chemical formula or chemical compound would weigh. So we're going to look at grams each unit on the periodic table has a your atomic mass or your atomic number is going to be your um, is going to be we're going to refer to that in grams. We'll be getting into this later, but it'll be grams per mole. But for our purposes right now, it's just going to be grams. So we're going to look at and figure out how much a piece of water, H2O, weighs. And the way that I came up with is a little more complex than other teachers do. But the reason I do that is because math has always been really hard for me. So try my way. If you can find a quicker, easier way, you do it yourself. But try my way first. So first thing I'm going to do is going to list the elements. We have H and we have O. Okay, so we have and you make a little grid. And this is going to be the number of pieces times the atomic mass. Okay, so we're going to have the number of pieces for H2O would be 2. And even though it's not written, there's a little tiny subscript 1. And so the number of pieces of oxygen would be 1 times the atomic mass. Now, if we go back to our periodic table, we know that our atomic mass for hydrogen is 1, and our atomic mass for oxygen is 16. Now, I have provided a periodic table that has rounded atomic masses. If you're using an atomic table, a periodic table that has exact averages, include those. But for our purposes, the atomic mass of hydrogen is 1. The atomic mass of oxygen is 16. So 2 times 1 is 2. 1 times 16 is 16. 16 plus 2 is 18. And that's how we figure out for the atomic mass. Oh, that'd be 18 grams. So now we're going to look at our molar masses, and we're going to choose something. Let's choose 4. And 4 is going to have, we're going to list our elements again, C and H. And we're going to make our grid, and we're going to do the number of times, I'm just going to put the hashtag. So hashtag meaning number, so the number of pieces. Remember, there's a hidden 1 as a subscript, so your number of pieces would be 1. And then your number of pieces for hydrogen would be 4 right there. And then we're going to multiply by the atomic mass. So the atomic mass for carbon is 12. And so we would write 12. And then the atomic mass for hydrogen, based on our previous H2O, we know that the atomic mass for hydrogen would be 1. So 1 times 12 is 12. 4 times 1 is 4. 12 plus 4 is 16. So the atomic mass, the molar mass of the formula CH4, which would be methane, which is in lighters and in the flatulence of mammals, is 16. So 16 grams.